Hello and welcome to our first developer workshop. I'm Lido, ecosystem lead here at Saros, and I'm really excited to kick off this new series. In today's first session, we're going to build a pool distribution viewer so you'll get hands-on experience with our SDK while creating something useful that you can build upon after. Before we begin, let's review our SDKs. Currently, we have 3. Our legacy SDK that handles the original AMM pools and staking, and then we have our 2 new SDKs with support for dynamic liquidity market making, one in Rust and one in TypeScript. For the remainder of the workshops, we'll be using the TypeScript SDK. If you're not familiar with DLMM yet, no worries. We'll pick up the important concepts as we go, but if you want a solid foundation first, feel free to pause here and check out our intro guide in our docs. For everyone else, let's jump into what we're actually building today. Alright, so we'll build a bin distribution viewer that shows how liquidity is spread across bins in a DLMM pool on Saros. At the end of this session, we'll have a complete component similar to this one. I've actually included the chart component in the template repo, which you can download here. This data is useful for liquidity providers who want to see a deeper look at pool liquidity before creating a new position. Showing capital distribution can help identify any gaps in the market. Along the way today, we'll cover how to fetch pool data, calculate live pricing, work with DLMM's bin structure, and really understand how concentrated liquidity works under the hood. By the time we're done, you'll have a working tool and the foundation to build more complex DLMM applications. Alright, now let's jump into the code and get started. Alright, so today we'll be working in the template repo provided so that it's easy for everyone to follow along. The template is simply a lightweight Next.js codebase with some starter functions, the Saros SDK, and some UI packages we'll use later on. As I mentioned before, you can head to this website and download a copy yourself. On the left over here, you can see my code editor with the template open. As you can see, there's some files throwing errors, and that's because we haven't installed our packages yet. Today we'll be using npm as our package manager. npm will simply install the packages listed in your package JSON. The most important one and the focus of today will be the DLMM SDK package. So to install our packages, we need to open the terminal and run npm install. Alright, it looks like our packages were successfully installed and we no longer have errors. Next, we're going to start the development server, so we'll run npm run dev. And you can see the server is successfully started. So I'm going to open a new tab in my browser as well as open the developer console. Now let's head to our server. Great. We see the UI rendered as well as a log in the console. This content you see here is coming from page.tsx, and this is the only UI file currently in the Next.js template repo, and it is displaying what you see here. By the end of this session, we'll have this looking like the one we saw earlier today. You can see here that we're calling this get bin liquidity function, which is actually defined in this DLMM file, so we're going to head into it, and we can see the to-do that this needs to be implemented, as well as this other helper function, and that's exactly where this log is coming from. Aside from that, I've also included the basic initialization for the SDK liquidity book service, which we'll be using in just a sec. But before we get started, we'll need a pool address, which is the contract address for the liquidity pool stored on chain. So to find one, we're going to head to the DLMM Saros site. And you can see here on the home page, we have a list of well, not all, but some of the top performing pools based on 24-hour volume. And you can see some information on the volume, the liquidity, the fees as well as an APR. So I'm going to click into one, and here we can see the details, and this is actually where users can provide liquidity, see their performance, and remove liquidity. And we can see this address here. So I'm going to go ahead and grab this address for the USDC USDT pool pair, which is a stablecoin pair, and we'll be using it for the rest of the demo today as we build out the liquidity bin distribution viewer. So I've grabbed the address and I'm going to place it here. Great. But as I mentioned, we have this service, we're still not using it. So the next step is we're going to build this fetch pool info, where we'll fetch the pool metadata, take a look at the data we're receiving, and then try and get a quote, which will produce the actual price if you were to go and make a swap using either or within this pool currently. So the first thing we're going to do is use our DLMM service and call the fetch pool metadata function. Then we'll log the return in the console and take a look at what we get. So let's define metadata, and then we'll await because it's an asynchronous function. And then we'll use the pool address, which is input here, but as you can see is getting passed into fetch pool info within the main function we'll be defining, which is the one called in page. And then let's just make sure we log it. Now, before we look at the results, I should mention that you'll want to make a .env file and add an RPC URL defined as this. You can get a free RPC URL for testing and development on a lot of services. Just do a quick Google, you should find one. And once that's complete, then we'll head over to the browser and refresh it. And great, we can see our pool info log coming from line 20 here, and we can take a look at the results. So the reason we need the RPC URL is because under the hood, the Saros DLMM SDK is actually hitting the blockchain and reading the appropriate data on chain for the pool address we're interested in. And what it's doing under the hood is kind of helping us turn that data into more meaningful information. Now, if we look at the data returned, we can see we get a base mint, a base reserve, this object extra, the pool address, a quote mint, quote reserve, and then the trade fee. So let's talk about what this data is. The pool address is the same address we input, so that looks good, it checks out. And then starting at the top, we have the base mint. So the base mint will actually be the mint address for the base token, which is USDC here. And the base reserve tells us information about how much USDC is in the pool currently. Then the same for the quote mint and the quote reserve for the second token in the pair. And then we see the trade fee is at 0.01. And that's also what the website's showing, so that also looks good. And if we open this extra object, we can see that we have token base decimal and token quote decimal. This is because blockchain stores everything as big integers for precision. So what this is telling us is that USDC and USDT are using 6 decimals. So that means 1 USDC is stored as 1 million on chain. Later on, when we jump into working with the bin data, you'll see this same pattern again, where the raw amount is stored as well as the token decimals. And so to save us, we're going to define a helper function that will calculate the actual token amount. So we'll do this in the utils file. If you see, we have something similar, which helps make the numbers that we display in the chart pretty, and you'll see that later on. But for now, we'll define a new function to calculate these actual token amounts from the raw amount. So let's get started here. So we'll define a new function and export it. Let's call it calculate token amount, and it'll take the token amount, and to be safe, we'll allow string or number, and then the decimals. So on our stable pool, that would represent, for example, the base reserve and the base decimal, or on the other side, the quote reserve and the quote decimal. So we'll have this helper return the amount as a number, so it's easy to work with. And we'll add one little safety guard. So if neither of our values exist, we don't want to perform the math, which would fail, or return 0. Otherwise, we'll return the amount, which we'll cast as a number, divided by 10 to the power of our quote, of our decimals. So in TypeScript, that is of 10 to the decimals. Great. So next, let's quickly test this function on the metadata that we recently fetched. So this log here is logging the value you see. So let's define the base amount and use our new function. So for amount, we'll take the metadata dot base reserve comma, and then the decimal is stored in the extra object, so extra dot sweet. And we'll do the same for the quote amount. And then we'll log the results and take a look at what we have. Oops. And if we refresh, great. We see the actual amounts logged here, and we see about 472,000 and a little over 20,000. So let's say 492,000. And if you remember, the pool is actually USDC and USDT. So we can just assume the price here is $1. And if you look at the pool on Saros, you can see the liquidity is at 492,000, which is very close to the value we just calculated. But assuming the price is 1, will only ever work on these stable pairs. And as we saw, the pools only require a base and a quote token. There's no restrictions, so these could often be paired with more volatile assets. And so we'll want to use the SDK next to get a quote of the actual price, to use that for pricing data, so we have more accurate data to display later on. So next, let's get a quote in our fetch pool info function. So first we'll define a variable for the price and just set it to 1. And then we will actually get a quote using our service again, and then the quote function. So if we look at this, it'll take the amount, which will be in big int, and then the metadata, which we fetched prior, and then these optional parameters, which we'll set. So for amount, we'll pass 1,000,000. And this will just be 1 USDC, accounting for the big int. So this is 6 decimals. And then for metadata, we'll pass the metadata we fetched at the start. And then for the optional is exact input, we'll put to true because we want a quote for 1. and swap for Y is true because we want to get USDT. And we'll set the slippage to 0.5. So we have a couple errors here. The first is just TypeScript complaining about the usage here, which will go away. The second is, again, TypeScript complaining, but also we need to check the type of this function. So it's a promise. So we'll want to await. And then let's just log the quote and see what we get. Great. So we were able to get a quote in the pool here. And we see we get the amount in and the amount out, as well as the offset and a price impact. So what this means is for 1 million units of USDC, we'll get in return 1,099 units of USDT. So we'll use our helper function again to convert that token amount. And we'll take the quote result, the amount out, and we'll also include, again, the decimals for the quote. And our function is complaining because we need to support big int type, which is the type being returned from the SDK here. So let's update our helper to also accept big int and save. Cool. And TypeScript is complaining because my editor updated this to a constant, so we should be good now. And then let's log the result. So we should expect this to be just above $1. Awesome. So now we see that value as expected, and it's very close to $1, but now we have the actual rate within the pool. And now we need to find the center of the trading activity, which is the active bin. The active bin is where both USDC and USDT exist together, and it's the bin where trading is happening now and where fees are being earned. So to get that information, we'll use the get pair account function from the SDK. And so let's continue right along in our fetch pool info function. So get pair account actually will take the pool address as a public key, so we'll need to define that. And we'll import it from the Solana SDK. Oh.
Yes.
Actually, we are passing it, so we can use it. And then we'll fetch the pair account using the SDK. And pass the public key. So we can log the results real quick.
Please.
Great, we got a result. And what we're most interested in is these first two. The active ID is the ID for the bin that is active, and then the bin step, which is the distance between the bins. So let's quickly define variables for the active bin, as well as the bin step, which we'll want to return at the end of this function. And then the last thing we'll want to fetch about the pool is the bin array data, which will actually hold details on each discrete bin. And so bins are stored in groups of 256 on the blockchain. So we'll calculate which storage box contains our active bin and then fetch that entire array. Some bins will be empty and some will have one or the other, and then the active bin will have both. So first we'll calculate the active bin array index. By just dividing the active ID by the 256. And then we'll again use the SDK to get the bin array info. And we can see the params require this object. So we'll need to pass in a bin array index, the pair, public key, and then a pair. So we'll pass our active bin array index, and then for the pair, we'll pass the pool pub key. And then for pair, not important here, so we'll just pass the pool pub key. Great. And to be safe, we can log these values. Great. We see our bin step as well as the active bin ID, and then the result of the get bin array info, which is a collection of all the bins. Perfect. And now we have everything we need to understand the pool's liquidity. So let's clean up our helper function and return the data. First, we'll define the return type, and we'll return the metadata, the current price which we calculated, the active bin, the bin step, and finally the bin array info, which we'll use to calculate the liquidity and visualize it amongst each bin. And we'll use the spread operator to pass the bin arrays as well as the result index. And then let's clean up these console logs. And we can remove these for now. Great. And now we'll get started on our final function, get bin liquidity. So we can destructure the results here. Actually, you can just take this. Oops. And we'll be using all of this data to calculate and format the liquidity data amongst the bins and prepare it for our chart. So let's use the current price again to calculate the total liquidity. We'll take the liquidity for the base token and multiply it by the bin price from the quote we got, and then calculated the adjustment for the bin. And we'll add this to the amount in the quote token divided by the bin price. And this will get us the total amount in USD value within the bin. So lastly, we'll add it to our return array.
BUIDL.
So we'll push a new object into the array, including the information. Great. And now we can save it. And now we'll want to update the return so it actually returns our bin liquidity data. And save. So now it should be returning our array for the interface. And then it's getting fetched here on mount in the use effect and being set into our hook state, which is then provided to the chart component. So if we refresh, awesome. So now our bin distribution chart finally has the data, and we're able to see the bins visualized here. I've included some filtering for the display to make it more focused around the active bin. Feel free to adjust it later on, however you want, in the bin distribution component. But for now, let's take a look at this. And we can see the active bin is highlighted, and this is where it's traded right now. And because it's a stable pair, you can see a lot of LPers are concentrating their liquidity heavily around the current price, which doesn't move often because, again, they're both stables. And so they're trying to provide more liquidity around the active zone so that they can partake in those fees. And you can see that these other bins also have liquidity, but it's much smaller to the amount around this active range. And then in the tooltip, when you hover, you can see the full data for each bin, which is all the data that we did right here in the get bin liquidity as we parsed each bin that we fetched around the active zone. And you can see it here. So some cool things you could add here would be a way to search the token, so perhaps like an input for the pool address, or even better, using the SDK to fetch the top pools by volume, say, and display these already for each pair. Additionally, a way to navigate the zone, so we only calculated the one array, which included the active bin. It would be cool to add some additional calls to see the liquidity around here, so especially on the left side here, which we're missing. And that would be a really useful analytic tool for LPers and users to be able to visualize and make better decisions while they're adding liquidity to pools on Saros. And that will conclude the live coding for our first workshop. If you made it this far, go ahead and give yourself a pat on the back. That was a lot of work, and we learned a ton about how concentrated pools, specifically DLMM on Saros, operate, as well as tons of hands-on work with the actual SDK. Some next steps would be to check out our bounties on Super Team Earn, which are actually live right now, and we'll have a few more coming out soon. And make sure you join the developer community on Telegram as we're starting to grow. It's Saros Dev Station, and please feel free to share any questions or feedback from this workshop there, and I'll be happy to answer. And then lastly, make sure you're following us on Twitter to stay up to date. We'll have a big hackathon coming soon, so all of this is great work to get ahead and be ready for when the hackathon launches. Thank you.